Okay, it's being recorded. So let's see here. The question we had was number 8 in this section. So given the function, find the vertex, determine maximum minimum value, the range, the intervals of increasing, decreasing. All right. Chapter 3, section 3. So we have f of x equals 2x squared plus 4x minus 48. Okay, so what A is 2, B is 4. Well, it's just, we'll do it both ways. It should be the same. Proportionally, it should be the same. We're gonna try with this, and then also all these are even numbers, so we could also divide each of these by 2, giving us x squared plus 2x minus 24. So if we divide each one of these by 2, we get that. So the A, B, and C here are those. So the first thing we look at is to find the vertex. The formula for the vertex is negative b over 2a. So we have negative 4 over 2 times 2. Negative 4 over 4, which is 1. So that's the x component, is 1. Let's try this also the other side. Negative b over 2a. Negative b is 2. 2 times 1. Negative 2 over 2 is negative 1. Yeah, it's negative 1. I'm sorry, it's negative 1. Negative 1. So yeah, so far so good. The y value is the function at this x point. So we have 2 times negative 1 squared plus 4 times negative 1 minus 48. Yeah, I'm working both ways, yeah. Negative 1 squared is 1, so it's 2 times 1. 4 times negative 1. 2 times 1 is 2. Positive times negative is negative. 4 times 1 is 4. Minus 48. 2 minus 4. 4 is bigger than 2, so it's negative. 4 minus 2 is 2. Negative. Since they're both negative, answer is negative. 48 plus 2 is 50. So the vertex, which quadrant? Did we ever go over what the quadrant? Yeah, we did. I thought we did. The quadrants go in this way. Yeah, so from the origin, you go left 1 and then down, so you're in the third quadrant. So we have the same thing here at negative 1. Negative 1 squared, 2 times negative 1 minus 24. 1 minus 2, 4. Negative 1 minus 24 is negative 25. Okay. what happened here, you notice how much smaller is this one than this one? Where did the half come from? Yeah, you've divided everybody by 2. So, well, this is the A value. This is your A value you have to worry about. You put that back in at the end. So yeah, I see where you're getting confused because they're not the same value, because this one is half that much because we divided by 2 at the beginning. So what we have to do here that's where we get our vertex from. If you remember, well, I'll show you why that came from. That comes from the complete the square reason. When you complete the square, the first thing you do is factor it out. It always stays in front. So that'll when you find the vertex, you multiply it by whatever that coefficient is. Okay. Yes. So yeah, it's going to be the same things.
That's not why they went wrong for me, because I didn't do that reduction.
Okay, so there's the vertex. The vertex is at -1, -50. The axis of symmetry is where? X equals -1. Does it have a maximum or minimum? It has a minimum because A is 2, and that's greater than 0. And the minimum value is at -50. Okay, so here's our rough sketch of our picture. -1, -50. So we have a dot there. We have the y-intercept at -48. So at 348, we have another one there. One, two, three, four. 2, 3, 4, 5, 6. Our intercepts are going to be at +6, +4, -6. I'll show you in a second. I'll show you in a second. So since we know our graph opens upwards, we have a minimum because our graph opens up because our coefficient is positive. So our interval of decreasing is from where? The graph is decreasing from -infinity to -1. So -infinity to -1, that's decreasing because it's going down. Then at -1, it starts going up. So at -1 to +infinity. This is where it goes down. This is where it goes back up. All right, so look at where we find the X-intercepts. Let's go to get the X-intercepts. To get the X-intercepts, the X-intercept is found when the value of y is equal to what? 0. So I'll set the y values equal to 0. You're back. Everything okay? Okay. So now This side's going to be easier. Since it has no coefficient in front, this side's going to be a little bit easier. I'll show you how to do this one, a shortcut for this one. So what times what equals x squared? X and x. Remember look at the first term. The second step is look at the second sign. If it's negative, it tells us what? Opposite signs. One's positive, one's negative. And the bigger number is going to be positive. So what times what's 24? When you subtract them, you get 2. 6 times 4. So 6 and 4. Set both of those equal to 0. The first sign. The bigger number gets the first sign. So x is equal to -6. X is equal to 4. Okay. No, it's whatever the first sign is. This one just tells us if they're the same or different. This one tells us which one the bigger gets, if it's negative. If it's positive, if this is positive, then they're both the sign. So let's look at if we have a leading coefficient. Because remember, it's easier if you have a 1. But if you have a leading coefficient, let's not even worry about it. Let's just put that leading coefficient in both of those. Just whatever this leading coefficient is, that goes in both of those spaces. Again, look at the second sign. It's minus, so it tells us it's going to be opposite signs. Now here's the difference. In this other method, if you have a leading coefficient, take the first term times the last. So 2x, and what's squared, times -48. You get 96x. So you take the first 2 terms, multiply them together. It's the numbers you're worried about, not really the x. You know the x is going to have to be there. Now we figure out what times what equals 96, because it's a minus. When you subtract them, you get 4. So let's look what equals 96. We have 96 times 1, but 96 minus 1 does not equal 4. You have 48 times 2. So we're getting closer. Does not equal 4. So this equals 96. This one equals 40, 90, 44, 46. What else do we have? We have half of this is what? 24 times 4. 24 times 4 is 96, but 24 minus 4 is 20. That's not right. 12 times 8 is 96. 12 minus 8 is 4. So we know the 2 numbers are 12 and 8. So again, since the first sign's plus, the 12 goes there. The 12 goes in the first. So far, so good. So again, take the first and last numbers, multiply them together, and try to figure out what combinations they have. Now we're right here. And right there. We never got rid of the leading coefficient in the first step. So in this step, factor out what you can. What do they both have in common? They both have a 2. If I take out a 2, what do I have left? Yeah, whenever you factor something out, just divide by it for the inside. The 2's cancel, you get X. 12 divided by 2 is 6. How about the second one? So we get so this is where we got rid of the original 2's. Just delete these, get rid of them. This is your factor. Set both of those equal to 0. And you see it's exactly the same answer as our other one. So that's how that works. So if you ever have a coefficient, don't worry about factoring it out or anything. Just go ahead and put it in the front one, multiply the first times the last, and try to figure out what it equals. That's the hardest part, is just multiplication and subtraction or addition. This, yeah. This, yeah, that's where the first sign comes in. The second sign only tells us what the signs are going to be. Okay. So that takes care of chapter 3. Hopefully everybody's okay with that so far. Okay, chapter 3, section 4. Rationals and radicals. What's a rational equation look like? Yeah, this is a fractions. Radicals, like that. It could be, this is called an nth root. It doesn't have to be square root. It could be any root. So with rationals, let's look at the rationals first. The basic rule here is get rid of the fractions. The first one, y squared equals y plus 3 equals 9 y plus 3. Is this an equation or an expression? How do we know? There's an equal sign. Yeah, it's an equation. So the first step, find the LCD, which is what in this case? Yeah, because that's one number. You have to make sure these have to stay together. The biggest mistake students do with this stuff is they try to cancel some of these numbers out. You can't do that because this is one number. It has to stay together. So the second step, multiply the LCD to each term. Just multiply it to each term. Remember what the third step was? Yeah, reduce, cancel. So the y plus 3 and y plus 3 cancel, y plus 3 and y plus 3. So all we're left with is that. Multiply to get rid of the parentheses, and then solve. There's two ways we could solve this one. Yeah, one way is the square root method. Since we only have two terms and one of them is squared and one of them is a constant, we can square root both sides. The square and the square root cancel. Square root of 9 is. So is that the answer? No. It's half the answer. Remember, whenever you square root a squared number, you have to put a plus or minus in front of the other side. Whenever you square root a squared term, you have to put a plus or minus because there has to be two answers. So those are our answers. X or y equals 3, y equals -3. Another way you can do it. This is called the square root method. The other way is by factoring using the difference of two squares. All right, the difference of two squares. What that one says is if I have two numbers that are both squared terms and I'm subtracting them, I can factor it having the same numbers, A and B. One's positive, one's negative. So A squared minus B squared equals A plus B, A minus B. That's the difference of two squares. This works with only for quadratics. So since this is a quadratic, what we should do is set it equal to 0. Has to be equal to 0 first before we do this. So we have y squared, that's a squared term. What's 9 made up of? So it's 3 squared. So they're both squared terms and there's a minus. So I know I'm gonna have y and 3 in both of these. One's positive, one's negative. Take both of those and set them equal to 0, and you get your answers. Again, it works both ways. It's just choose your whatever method you want. But this only works if you have two squared terms and then it has a minus in the middle. If it has a plus in the middle, then we have another issue. We cannot use the difference of two squares. All right, so okay. Oh, but here's a caveat. There's a big but. since we have a rational equation, and X is on the bottom, we have some limitations of X, or on X, limitations on X. In other words, X cannot equal certain numbers. Take the denominator, set it equal to 0. Whatever X equals, you cannot use. So our denominator is what? Y plus 3. Set it equal to 0. Yeah, so when y equals -3, the bottom is 0, we can't have that. So this is our exception. So anywhere it's -3, we cannot use it. So our only answer is y equals 3. This value here, -3, is called an asymptote. An asymptote is the value that makes the bottom equal to 0. Okay. So, because in fractions, earlier we talked about these two when we talked about linear equations and talked about slopes. When we talk about undefined and infinite slopes, or undefined and zeros, whenever 0 is on top, 3 goes into 0 times. But 0 goes into 3 infinite times, so it's undefined. You cannot have 0 on the bottom. So any value that makes the denominator, the bottom numbers, because we have numerator and denominator, that makes the denominator equal 0 is an asymptote.
So in calculus, we find that asymptote, but then we approach it.
As X approaches this from both sides, in this case, as X approaches -3 from the left, X, what happens to the graph? Does it go to infinity or negative infinity? I'm glad you brought that up. Remember this graph from a library of functions? This graph looks like this. Because the only thing you cannot have here is X cannot equal 0. So at the, when X is 0, that's the y-axis. Right. The graph gets infinitely close to it, but never touches. From the left side, it goes down to negative infinity. From the right side, it goes up to positive infinity. And So that's what we call it asymptote. The graphs will never touch it. Okay. Any questions so far? Let's look at some more examples. This is number 2. X plus 2 over X equals -3. Let's solve that one. X plus 2 over X equals 3. Remember, whenever you have fractions in an equal sign, always repeat the same process. First off, the only thing, now what can X not equal in our equation?
0.
So 0 cannot be an answer for our question because it'll make it undefined. It's an asymptote. So follow the same steps. First step, LCD, which is X. Multiply X to each term. So X times X, X times 2 over X, and X times -3. So whenever you have fractions in equal sign, find the LCD, multiply it to each term, reduce where possible, so the X's here cancel. So we reduce, multiply to get rid of the parentheses. So X times X is X squared plus 2. Negative times positive is negative 3X. And then solve. This is a quadratic. Remember, quadratics have to look like this. You have to set them equal to 0. So we got to move the 3X. X squared 3X plus 2 equals 0. Now, so we'll go ahead and factor this out. X goes in the first, that's what equals X. The second sign is a plus. What does that tell us? They're both the same. They're both the first sign. They're both plus. So what times what gives us 2? When you add them, you get 3. Now solve them. Set them both equal to 0. And remember, it's always going to be opposite sign of what's in there already. It's always going to be that. So if this is positive 2, we know the answer is negative. If it's positive 1. So those are our solutions to make this equation work. So far, so good. All right, let's try the third one. Ooh. Okay, now the third one. 4 over y plus 8 plus 9 over y squared minus 8y plus 64 equals 768 over y cubed plus 512.
Say that those come down.
No, no. Yeah, so it's y cubed plus 512. That's what that one says. All right, remember, these are all numbers. They have to stay together. We don't want polynomials on the bottom. Get rid of them as much as we can. So if you see exponents, that means we try to break them down to its linear terms, the binomials. So here we have one of them. That one's okay. Cannot break down any further. However, the middle one, this one, since it's a binomial, it's a quadratic, it's a trinomial, we can factor it out. We can try to factor it out if it's possible. If possible. What times what is 64? When you add them, you get 8. You can't. It's going to be too big. I mean, it's an imaginary number because if you add two numbers, the sum cannot be larger than the product. So what times was 64? I say 32 times 2, 32, or 4 times 16. That's 4 plus 16 is 20. So this one can't break down any further. So it's as far as it can go. Which is good. Because if it can't break down, that means there's a good chance that that may not be a real number, maybe imaginary number, so we can solve it. Now look at this now. The sum of two cubes. Remember we had the difference of two squares? Well, because cubics can be positive or negative, we have two different types. We have the sum of two cubes and we'll have a difference of two cubes. A cubed plus B cubed equals. In the first parenthesis, put everything you have under the exponents. So it's A plus B. Yeah, so the first one's going to be A squared, and the last one is going to be B squared. No. Because we have to have two terms in both of these. So that's A squared, that's B squared. So in the middle, we have A times B. Because inside the second parenthesis, you have to have two terms each, two numbers each term. So what are we missing? Are the signs. The last sign is always positive. Always positive. The first sign is the opposite. So since that's plus, this one has to be minus. No, of the first opposite of this leading term. Whatever that is, that's why it's arrow there. It's opposite. So let's look at an example here. Oops, no. X cubed plus 8. Is this the difference of two cubes or a sum of two cubes? Yeah, because 8 is 2 times 2 times 2. So our first parenthesis will have what? No, I'm not doing that yet. I'm showing you examples first before we jump in trying to do it. So in the first parenthesis, it's whatever's under the cubes. So it's x plus 2. Remember, this is your a value and this is your b. So in the second parenthesis, we have a squared, which is x squared, and plus b squared. What sign goes here? Yeah, since that's plus, this one has to be minus. And then in the middle is just multiply these two together. So it's 2 times x. And there's your factored form. That's as far as you can go. Okay, so let's look at ours. Y cubed plus 512. Well, it has to be. Okay, so if we don't have it in a calculator, let's break it down ourselves. We have 512. 2 goes in there how many times? 2 goes into 5 how many times? With 1 left over. So 2 goes into 11 how many times? With 1 left over. 2 goes into 12, 6. So you don't need calculators. I mean, this just practice using the brain. Okay, so that's as far as, how about this one? 2 goes in there. 2 goes into 2 once. 2 goes into 5 twice with 1 left over. And 2 goes into 16 8 times. Two goes into 12 6 times. 2 goes into 8 4 times. 64 is a perfect square of what? 8 times 8. So we have 512 is equal to 8 times 8 times 2 times 2. What is 2 times 2 times 2? Which is 8. So 512 is 8 cubed. Because here we have 2 times 2 is 4 times 2 is 8. There's 1 8. And then here's the other 2 8s. So we know this is the same thing as y cubed plus 8 cubed. What's the first parenthesis have? What goes in the first parenthesis? Y plus 8. In the second parenthesis, y squared minus 8 times y plus 8 squared. But 8 squared is what? 64. Which, if you look at it, is our denominators. Y plus 8, y minus 8, 8y squared minus 8y plus 64. So our LCD is what? This. That's our LCD. So let me rewrite that. So we have 4 over y plus 8 plus 9 over y squared minus 8y plus 64 equals 768 over y plus 8 y squared minus y8 plus 64. So what's our LCD? Yeah, that's our LCD.
Multiplied on one side and they're added.
Yes, but we do the same thing we did all the time. Whenever you have fractions and an equal sign, once you find the LCD, multiply it across. Because even if you did follow the old-fashioned way, you have to, before you add them, you have to have a common denominator. So this one, you have to multiply top and bottom by this. And this one, top and bottom by that. So all three of them have the same denominator. This is no different than if we had an example like it's no different. The LCD of this one is x plus 2. I simply put this in front of every term and go from there. Let me show you. My LCD, I multiply it to here, to here, to here. Y plus 8, y squared minus 8y plus 64 times 4 all over y plus 8. Y plus 8, y squared minus 8y plus 64 times 9 over y squared minus 8y plus 64. Y plus 8, y squared, 8y plus 64 times 768. Y plus 8, y squared, 8y plus 64. So we multiplied each term by the LCD. Remember, this is still the bottom here. I just multiplied on top. So what can cancel? Y plus 8, y squared minus 64, and then the whole line. There. After everything's said and done, this is what we have left. Multiply each term by the LCD, reduce, multiply, and then solve. Four times y squared is 4y squared. Positive times negative is negative. 4 times 8 is 32. And 4 times 64 is 256. 9y, 9 times 8, 72. Any questions so far? So all I did was to get rid of the parentheses, I multiplied the coefficient to each term. Simplify. 4y squared. Here's a negative 32y and a positive 9y. 32 is bigger, so it's negative. 32 minus 9 is 23y. 256 plus 72, they're both positive. 328. Just combine like terms. Now what do? Before that. No, before that. What does that have to equal to? Since it's quadratic, it has to equal to. Yes, so I get rid of this. $768 is bigger, so it's negative. 8 minus 8 is 0. 6 minus 2 is 4. 7 minus 3 is 4. Okay, you could try to factor this, or you could use what other method? Use the quadratic formula. Well, actually, since this case, always look for the middle, whatever the middle letter is, that's what you're solving for. So it's negative b plus or minus square root of b squared minus 4ac over 2a. We'll plug in a is 4, b is negative 23, and c is negative 440. So let me go top of a clean page. A equals 4. B equals -23. C equals -440. Negative b plus minus square root of b squared minus 4ac over 2a. Plug and play. So here's negative. What's b? B is -23. Plus or minus b is -23 squared. 4 times a times c. All that under the square root. And 2 times 4. Now we used to do order of operations. Negative of a negative is a positive. So it's positive 23 plus or minus. We also do the bottom. 2 times 4 is 8. Negative 23 times negative 23 is 529. So 3 times 3 is 9, 6, 6, 4, 529. Yes. Negative and negative is a positive. 4 times 4 is 16. 16 times 440. Six times 4 is 24. 26. 4, 4. 7040. Cool.
4049.
It's 4040. 440.
Well, after the next step.
Oh.
The square root is 40.
Let's get there. So we add those two numbers together. 7040 plus 529. So it's 9, 6. Okay, now what's 7569, the square root of it? If it's not a perfect square, then we won't worry about it. We'll just leave it as that. 87 over 8. So far, so good. I mean, nothing was really difficult. It's just all a bunch of math, adding, subtracting, multiplying. So now, because of this, we have two possible answers. Remember, this is y. So y is equal to 23 plus 87 over 8. And y equals 23 minus 87 over 8. We have to do one side that's plus, one side that's minus. This is the plus side, this is the minus. Seven plus 3 is 10. 110 over 8. 23 minus 87, 87 is bigger, so the answer is negative. 87 minus 23 is 64 over 8. So it's 2 goes in there 55 times. over 4. Thirteen 3/4. So it's 13. You can either, I'll probably leave it this. I don't think either one of these answers would work. That's your first intercept. Or the second one is 64 divided by 8 is, what is it? Right, 8. It's -8. But before we say what our answers are, what do we have to look at? Check for asymptotes. Remember, the original equation looked like this. How do we check for asymptotes? By solving the denominators. Set equal to 0. So y plus 8 equals 0. Y equals -8. So that's one number y cannot equal. And then the second one, y and y, second sign's a plus, so they're both negative. What times what? 64. When you add them, you get 8. There's nothing. So the only asymptote we have is y cannot equal -8. The reason I say that, look at our answer here. We can't use this answer. So that's our only answer we have. Well, because remember this one, when we factored it out, was both of these. Yeah, this one here was y plus 8, y squared minus 8y plus 64. So once we solve both of those, that one's already solved. All that work for one answer. Oh yeah, it is. It's a very, very long, arduous journey. Okay, those are rationals. Now let's look at radicals. This is question number 4. 4x minus 17 equals 1. Since there's an equal sign in a variable, we have to solve for it. So we have to get to the x. How do you do that? What's the first thing you have to do? How?
square each term.
Not each term. Well, okay, yeah, you say, because you can look at this one as two terms, yes, but each side, everything on both sides, right? So we have to square the left side and the right side. So the square root and the square cancel out. Equals 1 squared is 1. So add 17 to both sides. (17 plus 1 is 18. And divide by 4. You notice it never takes decimals as answers. It always leaves it either as a improper or proper fraction. You never see an answer as a decimal. Decimals don't tell us too much. Fractions tell us a whole bunch. Okay, so that's how you do that. Now, so hopefully let's look at higher order, higher root sizes, because if we had that, what would you have to do to get rid of the radical? Yeah, whatever's here, that's what you have to do to both sides. So that cancels. So we have x plus 2 equals 2 cubed is 8. Subtract 2. And there's your answer. For odd roots, these are the roots. That's called a root. X can be positive or negative. Even roots, X must be positive. So whatever's inside the radical, if it's a square root, or say it's a fourth root, whatever's inside there has to be positive. If the root is odd, like 3, 5, 7, 9, then inside there it can be positive or negative. It doesn't matter. Okay, let's go ahead and do this one. The next one is,
On that last one,
yes,
is that plus or minus? Is that plus or minus 6 or just 6?
just 6. That's a good question. Because it's an odd root, because if we can't change the sign, if it was a -6, then that would change the final answer. Positive times positive times positive is positive. Negative times negative times negative is negative. So that's a very good question. But also think about it. What's the difference? Let's see, get so over here can see it. If I gave you these two equations, let's say equals 4. What is the difference between the processes we have to do here? What do you have to do to this one? we have to square root both sides. So when I do that, the answer here could be positive or negative. Because of this square gets rid of the negatives, so it makes everything positive. But since this one's already set, square roots can only be equal positive when I square both sides. Then it has to be whatever the answer is. That's a very good question. I'm glad you asked that.
Thanks.
So whenever you square root a squared number, you have to put the plus or minus there. But when you square a square root, don't do anything. Or any even root, right? And hopefully we won't see too many equations that are big, ugly roots. So here's the next one. 5 minus x equals 17. So first step is what? Well, first off, you check, is this a valid question? Since it's a square, since it's an even root, is the answer positive? Yes. If it was negative, you couldn't go any further. You're done. It's imaginary. You can't graph it. You can't do anything. So square roots have to equal positive answers, or even roots have to equal something positive. What's that? Oops, oops. Yeah, if I have my hand under there with auto focusing, it focuses on my gorilla hand. So to get to the x, we have to square both sides. We have to get rid of the square root. Those cancels. We have 5 minus x. 17 times 17. 289. Subtract 5. Negative x equals 284. Change the sign. So x is equal to negative 284. You only put a plus or minus when you square root a squared term. We start off with a square root. You square a square root, you don't do anything. But when you square root a squared, because whenever you have a squared number, I could put positive or negative in there and it'll still equal a positive number. Now, if we plug that in there, so we have 5 minus a negative 284. Negative and negative becomes a positive. $289 square root equals 17. Check. Notice, since the x inside the radical is a negative, there's a very good chance that the answer will have to be negative to get rid of that negative sign. Because if this was a positive, what would happen? We'd have a huge negative number. It'd be negative 279. You cannot take a square root of a negative number. So you have to be very careful about that. Always check your answers. So what's the answer? Negative 284, correct. All right, a bigger radical. Fourth root. X squared minus 5 equals 2. Right. Since that's a 4, we have to take to the 4th power both sides because they have to cancel. X squared minus 5. 2 to the 4th is what? Two times 2 times 2 times 2. 4 times 4 is 60. You did 8 times 8. So get the x squared by itself. Add 5 to both sides. 16 plus 5 is 21. Oh, squared. Square root both sides. So x equals what? Plus or minus, very good. Right. Since 21 is made up of 2 primes, 7 times 3, it can't be factored out any further. Those are my 2 answers. But what we have to do here, we have to check it out. Check your answer, CYA. X equals positive square root of 21 and x equals negative square root of 21. Well, let's hope not, but let's see. Square root of 21 squared minus 5. Does that equal 2? Fourth root of negative square root of 21 squared does minus 5. Does that equal 2? Square root and the square cancel, so we have fourth root of 21 minus 5. 21 minus 5 is 16. Fourth root of 16, 4 times 4, 2 times 2. So 16 is 2 to the 4th. So there's 4 of them. So this one works. Negative squared is positive square root. So all that. So we're back to the same thing. So our answer, that is our valid answer. The reason I say check because we just saw an instant where it didn't, one of them didn't work. So whenever you deal with radicals, it's important that you isolate the radical first. You notice in every one of these examples, you always had the radical equals some number. Oop. We can't do anything with the radical until it's by itself. So we have to isolate the radical before getting rid of it. You have to isolate the radical before you can get rid of it. So it has to be by itself on one side. So yes, to solve, we have to isolate the radical. Case in point, look at this example. We have number 7. 5 plus x minus 7 equals 7. So is the radical by itself? No, so we have to get rid of it. Subtract 5 from both sides. X minus 7. 7 minus 5 is 2. Now it's by itself. Numbers over here. Okay, there's a couple of things. Is it by itself? Since it's an even root, is it a positive number? Because if it's negative, you're done. It's not real. It's imaginary. There are no real answers. Since it's positive and it's radical, square both sides. Two squared is 4. Solve for x. And then you can check your answer. 11 minus 7. 11 minus 7 is 4. Square root of 4 is 2. So that's your answer. It works. So always check your answer. Plug it in the original question, see if it works out. Number 8. X plus 4 plus 2 equals x. Right, we have to move the 2 across first. So we have square root of x plus 4 equals x minus 2. Now comes the tricky part. What do you do next? How many terms do I have?
Make the x minus 2 a single term.
Right, it has to be in parentheses because it is one term. I have to square both sides equally. Because it's not going to be x squared minus 2 squared. It's going to be x minus 2 squared, the whole thing. So the square roots and square cancel. So this one's going to be x minus 2 times x minus 2. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative, negative is a positive. 2 times 2 is 4. Negative, negative is negative 4x plus 4. Yes, since it's quadratic, we have to move everything over to one side. It has to be equal to 0. since it's quadratic, anytime you have a polynomial, any order of power, it has to be equal to 0. So we have to subtract x from both sides, and we have to subtract 4 from both sides. Negative 5x minus 1x, negative 4x minus 1x is negative 5x. The 4's cancel. Actually, this is the easiest type we can get. Does everybody follow me so far how I got this point? I had to square both sides, FOIL it out, move everything to one side. Now I got to solve it. Factor it first. What do they both have in common? I can factor out 1x. If I take out 1x, all I'm left with is x minus 5. So I took away 1x from both of these. Set both of these equal to 0. Anywhere you see an x, set it equal to 0. There's our first answer. And there's our second answer. Are those our answers?
So the x equals 0 is because throw on the left side.
Well, yeah, because I think this equation, that's an equation. Set it equal, anywhere you see an x over here, set it equal to 0. Always check your answers. X plus 4 plus 2 equals x. X plus 4 plus 2 equals x. So x equals 0 and x equals 5. Zero plus 4 plus 2 equals 0. Square root of 4, 2 plus 2. Does 4 equal 0? No. So we cannot use 0 as an answer. Same thing on the other side. Anywhere I see an x, I put a 5 in its place. 5 plus 4 is 9. Square root of 9 is 3. So the only answer we have is x equals 5. Got a question? Did I lose you somewhere? Or from the beginning? Okay, where at? On this one here? Okay, so once I finish, you got it down here, right? So once I get to that point, I take both of these and plug them back into the original equation. So here's the original equation. Anywhere I see an x, I put a 0. 0 plus 4 plus 2 equals 0. 0 plus 4 is 4. Square root of 4 is 2. 2 plus 2. Does it equal 0? No. And then this out here. Yeah, this is just a check section. All right. Number 9. X to the 1/5 power equals -2. Okay, here, what I have to do is I have to explain to you what the rules are for exponents. Yeah, so I remember our so when we have here is a general structure of a radical equation. Whatever's inside here could be set to some power, and you have the root. You can rewrite this as a fraction. Whatever's inside goes on top. Whatever's in the root goes on the bottom. Oop, and so the root always goes on the bottom. It's what's divided. And that exponent's on top. So if I had that, I could rewrite it as a exponent 4 divided by 3. Whatever's on the inside goes on top. Whatever's in the V goes on the bottom. X to the power 5/7. Because it's a fraction, I know it's a radical. X goes inside there. Whatever's on top goes inside. Whatever's on the bottom, there. So in our case, this is the same thing as is that a valid statement? Can an odd root equal a negative answer? Yes, only odds. If it's even, it cannot equal negative, so you're done. But since it's odd, we can do it. How do we fix that? Raise both sides to 5. So those cancel. -2 times -2 times -2 times -2 times -2. Because it's odd, we know the answer is going to be negative. 2 times 2 is 4, times 2 is 8, 16, 32. There's your answer. That's what X has to equal. Difficult? It's just a different way of writing it. In other words, you can convert it, or you could look at this. Whatever's on the bottom raise it to both sides.
Yeah, the hardest part about calculus is that you gotta know all the algebra.
So algebra is the queen of all mathematics. Okay, so basically if I have this format here, if I have any fraction, to get rid of that, I simply multiply it by the reciprocal. And that's what I have to put to both sides. So if I had that equation, what do I have to raise it to? To both sides. The 7s cancel and the 5s cancel. So we just have X. This is same thing as 1 2/5. So we have 2, 1 2/5. Because it's a mixed number, I break it down into 2 parts. So I have 2 5th root of 2 squared. There's your answer. So far, so good. There's a lot of moving parts, but it's pretty much straightforward. Whatever you see in the power up here, you can either convert it to a radical and go from there, or you just go ahead and multiply by the reciprocal. Okay, here's the last one for the day. 1 over t plus 1 over r equals 1 over a. Solve for t. Nope. Remember, the same rules apply. We have fractions and the equal sign. What do you always do when you have fractions and equal signs? Yes, it is. TRA. Or we can say art. It's just all the denominators put together. Multiply the LCD to each term. So I just put that in front. So what cancels in the first one? The t's. So we have AR times 1. The r's cancel in the second one, so we have AT1. And the a's cancel, so we have RT times 1. Multiply to get rid of the parentheses, so we have AR times 1, AT times 1, and RT times 1. Now we have to solve. We have to solve for t. But you see t's on both sides, right? So we have to get it to one side. Since you're solving for t, it has to be on one side. So I'm subtracting 8t from that side. Now, I could normally in a long semester, I would let y'all waffle here and try to figure out how do we solve for t? You'll say divide by r. No, you still have that one there. But what do you notice about both of these equations? What do they have in common? They don't have an a and r in common. These both have a t in common. So what if they have it in common? I can factor it out. Now there's t. I want to get rid of this, so I divide both sides by r minus a. That cancels. So t is equal to ar r minus a. It looks tricky, but again, you have to use all the rules you can. You're solved for t. Once t is by itself, you're done. As my professor's QED, quid et demonstratum. What I was supposed to show you today, I did. That's what it says in Greek. Quid et demonstratum. Okay, any questions, anybody? I know, actually, I hope it didn't go too fast this time. Because no, if I ever go fast, please stop me. I have no problem slowing down. Oh, yes, we are. Oh, yes, me too. I got like 5 minutes. All right, everybody. So I will see everybody on Monday. Have a great weekend, everybody. If you have any questions, just holler. I'll Zoom on the weekend if you want to. All right, everybody.
Thank you.
All right, take care.
All ages will be able to get vaccinated.
Starting Friday.